Okay, so I've started the recording. So, first of all, thank you everyone for joining this session. I know it's Saturday evening for Saturday morning for most of you guys, so I really appreciate it. So, this session is all about DevOps, AI ops, LLM ops, all these buzzwords, and something about the cloud infrastructure. Uh, I will start with the brief introduction. So, hi everyone, I'm Prashant. I'm in this IT field for close to 19 years now. I worked for various companies. I started with SCL, then Red Hat, then Cognizant, and currently I'm working with Salesforce here in Bay Area. So I wrote three books so far. One related to AWS, and then second one is regarding DevOps, and there's one more related to the LLM ops. So I will share the link of those books at the end of this presentation. Two of them, they are completely free of cost, so please feel free to download it and share any feedback. So first of all, I would like to thank Jaypee University for providing me this opportunity. Uh, somehow, second issue. Okay.
Excuse me, sir. Firstly, I
Uh-huh.
wanted to introduce you with our students.
Sure. Yeah, whatever you feel comfortable. Yeah, can start with that.
Thank you, sir. Firstly, a very good morning to our esteemed guests and respected teachers and dear students. Now, I take the privilege to introduce a great personality whose presence is attractive and vibrant in our campus. And he is none other than Prashant Lakhera, sir. Prashant, he is a leading software engineer at Salesforce at San Francisco, and he has a flourish working experience of 18 years at open source. And I'm feeling so glad in telling you and sharing with you this thing that he is also an author of three books. Now, without any waste of time, I would like to call Prashant sir to address all of us and share their thoughts with our students. Please, sir.
Yeah, thank you so much, Rahul, for this nice introduction. So yeah, you have already covered the introduction part, so I will skip that. And I really appreciate JP University for providing me this incredible opportunity to deliver today's presentation. Um, just want to set up the clear expectation. Like I mentioned, I'm working on this IT field for close to 19 years. So, I mean, whatever I've learned in this 19 years, I mean, it's really difficult to condense that into 1 hour session. So, but don't worry. At the end of the session, I'm going to share my LinkedIn profile. So, if you have any question after the presentation, just feel free to ping me. Just because of time reference, I might be a little late to answer your question, but I will try my best to answer any questions. Secondly, I want to make this session interactive. So I want some active participation from you guys. I don't want it to be like a death of PowerPoint. So I want you guys to be more involved in the session. Try to answer any question. If you have any doubt, please raise your hand or put it in the chat window. So in this way, it will be more interactive from both of the sides. So let's get to the meat of like what exactly the topic for today's presentation. First of all, we will start with the DevOps, and I will try to make it more in a way that how it is being used in the industry rather than telling you some theoretical things. So how DevOps works, how DevOps flow work, how the code is reached from all the way from your development machine all the way to the production. Secondly, I'm going to talk about the one of the hottest trend right now is LLM ops or AI ops, and finally the bonus part. Any questions so far before I start the presentation? Okay, I will take this as a yes. So first thing is DevOps. So how many of you heard about DevOps and what do you think exactly the DevOps is? And like I mentioned, I want to make this presentation interactive. So I want the active participation from you guys. So yeah, Bridge, go ahead. are on mute if you are talking. While we are waiting for Bridge, anyone else? Okay, just in the interest of time, as you can see, DevOps is made up of two fields. One is called Dev, and second part is the Ops. So Dev means a developer, like any of you guys, or even you guys, maybe the operation people in the future. So developer, as we all know, is the person who writes the code, right? You can write the code in any language. It can be on Python, it can be Go, Java, JavaScript, any language you are going to write the code. Ops is the people, or the operation are the people. You may heard the word like system engineer, the site reliability engineer. These are the people who deploy that code into production. Now, what is the deployment part? I'm going to discuss more about it. But clearly, as you can see, the DevOps is made up of two words. The dev part, the person who's writing the code, and the ops part, the operation person who is going to deploy that code. Now, the problem with that approach is that once the developer writes the code, he tests it, and he gave it to the operation people to deploy that code into production environment. And production means where your code is running. So for example, I can take an example of google.com. So they have some kind of a production environment through which you can access a site like, for example, google.com. Now the problem arises like the developer who writes the code, he gave it to the operation people, and operation people, when they deployed the code into production, and I'm just oversimplifying it because before deploying that code into a production, there are number of steps involved. Like no one deployed that code directly into production. There may be a different environment, like a QA environment, the quality analyst environment, where they test the code, or there may be a staging kind of environment, or a dev kind of environment where they deployed the code. And ultimately, when they tested all the way, the code will eventually go to the production, like whatever the code you have write. Now the problem arises is that when the operation people, the code you have written, you are trying to deploy that code into a production, that code does not work as expected. So when I'm talking about the code is not working as expected, like you are writing some functionality to your customer, and when the customer who is trying to access that functionality, he is facing some error. And developer on one hand, he said that he done his work, and his work or his code is working fine in the development environment. And while operation people is saying that when he's trying to deploy the code into production, it is not working as expected. So it create a silos, and silos in the sense that the developer, he has no idea how the operation people he's trying to deploy the code. And operation people is the person who doesn't have any idea how the code is written. So to break that silos, a field which is developed, which is called DevOps, where a developer who is writing the code. So maybe in future you guys are a developer who is writing the code. You guys have a knowledge like how this code will ultimately goes to the production, how it is ultimately deployed to the production. Like I mentioned, we are going to discuss more in details like how the deployment cycle works. On the other hand, the operation people who is deploying that code should have a knowledge how that code is written. So now developers has the knowledge about the operation side of it, and operation guy has the knowledge about the development side of it. Like he has the knowledge of a language. Like for example, if the code is written in Python, he should have a knowledge of Python. And again, just to reiterate that, the development guy, he has the knowledge how the code is deployed. So that is the basic gist of it, how this DevOps comes into picture. Before I move further, any question before I move to the next slide? Like everyone is clear with the concept, what is DevOps? I know it's Saturday morning for you guys, but can anyone give me a thumbs up or that you understand this concept of DevOps?
Yes, sir.
Okay, perfect. Uh, Rakam, you have any question?
Sir, my question is how to be a DevOps engineer, as in what have to be we have to be focus on what fundamentals to simply so we can be a DevOps.
Yeah, that's a really nice question, Rakam. So that is my next slide where I'm going to talk about how this whole entire workflow works. So yeah, uh, that will be the next point or next slide.
Okay, sir. Thank you, sir.
Any other question? Okay, so I will move forward. So this is basically the workflow. Like if anyone wants to be a DevOps engineer, what is the path forward? And this is what I am telling you based on my experience, like working on this industry for quite long. And to be honest with you, when I started my journey in this field, it was not called as a DevOps engineer. Mostly it is called Linux system administrator. Then it moved to system engineering, and then now the DevOps is the word. And Google has coined a new word called SRE, which is called site reliability engineer, which is doing the same thing. But um, by the end of this slide, you will have a better picture, like what exactly are all those. Okay. So if you want to be a DevOps engineer, or this slide is all about like how the code which you guys are writing or you guys are going to write in the future, how it will eventually end up in the production. So this is the most important slide. So let's say you guys are writing a code in Python, Go, or JavaScript or any other language. We always start with our laptop, right? And in laptop, every one of you guys who are a developer, you have your favorite editor. It can be as simple as Vim, which is a VI improve, Nano editor, or most of the people who nowadays using a tool like VS Code, which is by Microsoft, or there's a PyCharm by JetBrains. Uh, can any one of you tell me, or all of you guys, what is your favorite editor, or like which editor you guys are using to write your code? And it can be on any
It
language.
can be on any
VS Code.
VS Code.
Cool. And are you guys using any special extension or any of the plugin to write your code? Or any of you using like, for example, GitHub Copilot functionality uh, to use the like any of the LLMs which can help you guys to write the code? If not, I mean, it's fine. Yeah. So, okay. So we started with our local laptop where let's assume for this conversation, we are using VS Code. Even I use VS Code heavily to write all the code. And once I wrote the code, that code will not be, that code is of no use if it just been there in my laptop. So I need a centralized place where I can push the code. And that centralized place in most of the cases is some kind of a version control. And the version control in most of the cases is GitHub, Bitbucket, or GitLab. But the most popular one and the one which has been there for quite long is the GitHub. Now I use the word called version control. Any one of you knows why GitHub is called a version control or any of these like GitLab or Bitbucket called a version control? Anyone? This is much better slide. So basically all these things, they are called a version control. But why it is called a version control? Okay, sure. I mean, no worries. Even when I was in the college, I don't even know about all these GitHub and version control. So yeah, perfectly fine. So version control, let's say I'm writing a code, and for example, in my case, most of the time I wrote a code in Python language. So I wrote a code and I push it to the GitHub. Okay. And when I push that code into a GitHub, it will generate a version. So let's say it generate a version named version 1 for that code. Normally, I'm just trying to oversimplifying it, but normally it is a 40-digit hexadecimal character. Or maybe if I have time, let me show you guys how it exactly look like in real environment. So this is one of my repo. And if you look here, every time I push a code, it generates this hexadecimal number. And this hexadecimal number is called a version. So let's not worry about this big hexadecimal number. Let's say I'm pushing a code, and first time when I push the code, it creates a version which is now version 1. Now the code is perfectly running fine. And let's say I enhance the functionality of that code, and let's, for the sake of this conversation, I added some of the other functionality, like say exception handling to that code. And then I push that code with the exception handling capability back to the GitHub. Now, the second time with the exception handling capability, when I push the code to the GitHub, it is going to generate a version 2. So it knows that in the version 1, I only have those basic functionality. And in version 2, I have the extra functionality with the exception handling. Now, let's say that exception handling capability that I have added has some issue. And in the world of coding, we called it a bug. You probably have heard this word a lot of time. And we are going to discuss more about it. So what GitHub has provided, or actually it's not GitHub, it's Git who provide the functionality that I can revert back to the previous version. So from version 2, I can simply roll back to the previous version 1. And that is a really awesome functionality. I mean, it helped us a lot so that I can go back from one version to another version. So that is why it's called a version control. Okay. Even, I mean, this functionality is used by many other people nowadays. So for example, if you look at this Google Docs, even they have created the version. Like whenever you are going to add some text to it, it is create a version 1. And if you add other text to it, or you keep on adding the text to it, it will keep on creating a version of it. And again, the reason behind it is same. Let's say you want to move back to the previous version. Like, let's say today I have added some content to this talk, and tomorrow I added some more content to this talk. But let's say I want to go back to the whatever the content I've added in the previous day. So for that purpose, the version control is important. Any questions so far, or any confusion why it is called a version control, and what is the use of it? Okay, thanks. So version control is one functionality. GitHub provides a lot of other functionalities. And again, we are going to discuss that in just a short amount of time. But this is one of the best functionality, or this is one of the functionality where the GitHub shines. And GitHub, I'm just using that word loosely. Under the hood, it is running Git, a version control system. GitHub is just a UI on the top of that. Okay. So far, you as a developer, you have developed the code and you pushed it as a centralized repository like GitHub. And one of the functionality that I've told you is that, okay, you can version control it. I mean, GitHub is going to version control it. Second functionality is that you can share your code. So now the code that you have pushed, you can ask your fellow colleague that they can check that code. They can download that code in his local laptop. So it is much easier for you guys to collaborate. Okay. So that is where this whole version control concept comes in. Now, once the code is there, and like I mentioned, one of the other functionality of GitHub or any version control system is that you can share the code. And the other functionality it provides is called a code review. So any code you are pushing it to GitHub, it may or may not end up into your production environment. And the reason for that is that people will do a code review. And generally, how it works in the industry or in various companies, that you need to tag your team member that, okay, I have pushed this code, and now before it end up into production, please code review it. And the code review means that person is going to give you a feedback. Is that part is clear? Or I can show you with the help of an example. So let's say, give you a simple example. So I guess everyone is familiar with GitHub, or anyone here who's not familiar with GitHub here? Yes, no, maybe. Okay. So in
So,
GitHub,
yeah. So, here, like,
I will put myself on mute. Yeah, Suman, go ahead.
so sir, here we have students from second year, BTech second year. So they are just learning these things. So if you want to elaborate a little bit, that will be okay for us.
Sure. I mean, okay. So basically, this is what the GitHub console look like. And the first thing which most of the people do after creating the account on GitHub and everything is to create something called repository. Repository is a place where you are going to check in your code, or check in the code in the sense where you're going to put your code. So let's say I will name it as a demo repo. And it's up to you. You want to make it public or private. Public means it will be accessible to everyone, and private means it is only accessible to you or the people whom you want to share the code. Now, it is always a good idea to add a README file. README file is something which tells other people who is going to look at this repo that what is this repository is all about. So let me show you, for example, GitHub repo for Kubernetes. I think some of you are aware of this Kubernetes project, or I can take an example of anything. So if you go here, this is the README file. So basically in the README file, we put like what this project is all about, how to use this project, how to install this project, or how to install this code. So it is basically a good way how if anyone in future who's going to use your repository, how they're going to use this code. So that is the main aim of this README file. So it's always a good idea to put a README file. Then there's something called a git ignore. So basically, whenever you write a code, so let's say I wrote a code in Python. So what this will do, the git ignore that, let's say I'm compiling some code. Python is not a compiled language, but let's say in C, I'm going to compile the code. And C creates a binary as well as all the helper function along with it. And I just want to push the C binary, the compiled binary. I don't want to push all those helper functions, or let's say if any log file is generated. So in ignore, we can specify those options that don't push all those files. Just push my main code to the repository. Finally, we have the license. So this is the critical piece. Generally for open source, we go with this GNU public license, Apache license, MIT license. That means anyone will be able to use it. But whenever you guys start working in the company's environment or with some companies, generally they have their own specific license. So that means if a code is written inside that company without, yeah, without their permission, you cannot use that code. So for this, I'm just putting Apache license, which is freely available, and creating a repository. So now you can think of this is one place where I can push the code. And generally, if I need to bring this code to my laptop, I perform something called a git clone, which can be over HTTPS or SSH or anything. And there are some commands which we can use it for that purpose. I can show you guys. There's a command called git clone, and I will just use this. And if I do cd demo repo, now the content of that repo is now in my local laptop. If you don't want to do it, you even have the option to have something called, you can create a file here. Let's say I can create a test file and I say test content. And before you are going to commit that file to the Git, you need to write some commit message and this one. Now, I think we are diverging away from our main presentation, but I want to show you something called code review part. So basically what happened, most of the company, they uses this main branch, and branching means a different stream of work. And with different stream of work, I mean, let's say I created a branch called dev. So now in my case, I am going to use this branch for doing all my development work. Okay. And most of the company, like I mentioned, they use this main branch to push the code to the production environment. And production, I mean, where exactly your main website is running. So let's say this dev, and I created a new file called dev file. And I can put any content, dev content, and just for this demo. I will commit the change. And like I mentioned, we need to write a commit message. So this is fine. Okay. Now, where exactly the code review comes into play. So if I go back to this repo, it will say that I have just pushed a change to this dev repo. And in order to merge that code from dev to the main branch where it eventually ends into the production, I need to raise something called a pull request. And pull request is something which my team member is going to review it. This is where he's going to give me a feedback. And before that pull request is even been reviewed by my team member, GitHub is going to do some kind of a testing, some kind of a see that there's something called conflict, which is very, very common in any of the environment. Conflict means if you, me, and many developers, they are working on the same file and they are editing the same line. So if many people, they are editing the same file or the same line, then it will create a conflict. And in those cases, we need to work with the developer in order to understand why he's updating that same line at the same time. And we should, it's just more of a conversation kind of a thing to avoid these conflicts. So basically, your other team member, now he or she is going to review the code, see if the request is fine. He can check here that I created one commit, the number of files changed. You can see the content of this file. And if he or she is happy with those changes, he is going to approve the request like this. So generally we use a word called LGTM, which is look good to me, and submit for it. And merge the pull request. So now if you look at I made the change into the demo branch, but now you will see that the change is eventually been ended up into the production branch. So this is the workflow which most of the companies follow. And normally you do not have access to this main branch. This I'm doing it here for the demo purpose. Most of the cases we have access to like dev branch where we do most of our work. And from dev, somebody going to review my pull request and merge those changes into the main branch. And this I'm telling you, whichever company you go, they follow. If they're following the GitHub workflow, this is the workflow they follow. So maybe if you are in the second year, maybe in like 2 years down the lane, you will see like whenever you're working for some company, they are following this kind of a workflow. Any question before we move to the next section? Okay, thanks, man. Now, just to reiterate, we started with the code development where someone already, where you as a developer, you wrote a code. Then it goes to the version control where you push that code to the, okay. This is a very good question, Priyanshu. How do you keep multiple branches organized when working on big projects? So I can tell you based on my experience. So for example, uh, in any companies, the project is normally happen for like 3 months to 6 months. And when the project is been over, I mean, project is been pushed to the branch. So normally, I forget to tell you one thing. So let me do a quick change one more time. New file change, let's say. And again, I'm going to raise the pull request. Pull request, complete with that branch, create pull request. Okay, somehow I'm not seeing the option. But to answer your question, yeah, here. So normally what most of the people do, Priyanshu, is that they try to clean up those branches when they are merging the pull request. In this way, their workflow will be much, much cleaner. The long running branches is never good for any environment. So here you see that the moment I merge that pull request, I have the option to delete that branch. So in this way, I should not have a long running branches. Does that answer your question? Okay, I will take it as a yes. I know we are at 34 minutes over. So, okay, let me move to the next step. So now your colleague, he did the code review. The next step for this process is something called CI/CD pipeline. Again, just to make it interactive, anyone heard about these terms CI/CD and what are those? Okay, no worries. CI/CD stand for continuous integration and continuous deployment. So the main idea behind it is to have some kind of a continuous process running so that whenever you as a developer check in the code, it will be reviewed continuously, either manually or either by some kind of a automated process. So let's say as a part of a CI process, we write unit test. So unit test is basically to mimic the to mimic the environment. Sorry, not the production environment, but to mimic the environment. So let's say I'm writing a code where I'm trying to create a UI functionality or creating some UI functionality. So what unit test will do is just to mimic that functionality. So the main idea behind that is before we are going to push that code into a production, we are trying to catch any bug in that. And once the unit test functionality completely successful, then only we are going to push that code into production. Or then only we are going to merge that code into production. So that is a part of a CI part, continuous integration, like continuously running the unit test. So unit test, how the unit tests work is whenever you are going to push the code to your main repository in GitHub, the unit test will trigger off and it will see that that code you have pushed is not breaking any functionality. Similarly, let's say I'm writing a Python code and I use some of the modules, which let's say outdated module library. That module that I'm using may have some kind of a security vulnerability. So you can use some kind of a tools like the popular ones are Aqua or Sync, and you can continuously scan that code. So in this way, you will say that whatever code you're writing or whatever module you're writing does not have any kind of a bug or any kind of a security vulnerability. So all those checks we can done as a part of the CI/CD pipeline. Is that is part is clear? Like what is a part of a CI/CD? So basically, rather than me verifying all those things manually, we have an automation in place, and that automation is mainly be done by one of the popular tool called Jenkins, or nowadays we have something called a GitHub action. So basically, we are going to write a script. In Jenkins, there is something called Jenkins file, and GitHub, we have something called GitHub action. So those processes continuously run. The moment you're going to push the code, even a single line of a change, those things got triggered off, and we'll see that, for example, I gave you an example, unit test is passing, or your security vulnerability, there is no vulnerability in the code that you are pushing into the GitHub or any other source control system. Okay. So now we reached up to a stage, let's say my all the CI/CD pipeline, they are completely passing. My code is vulnerability free. It's passing the unit test. Now it's time to package that code. And there are multiple ways you can package that code. One of the famous way is called RPM, which is called Red Hat Package Manager. It has been devised by Red Hat to package that code. Or other ways, if you want to containerize that code, there is a popular containerization solution called Docker. Have you guys heard of Docker and or RPM? Anyone? Docker or RPM? Good. Yeah. Okay. Sure. So the main aim is to package that code before it has been pushed to a production. And with package means I just don't mean only the coding part. When you write a code, it has some dependency. So for example, if you're writing a C code, it has a dependency on library called glibc, okay, which is a libc package which is useful for which is providing you the system call. Or if you're writing a Python code, it has dependency on some kind of a module. Like let's say my code is going to do a request to the some external website. So for that purpose, I'm going to use a request module. Or if I need to do some kind of a mathematical calculation, let's say I'm using a NumPy library. So for that purpose, my the code which I'm going to package either by RPM or by Docker not only have that code but also have a dependency in it. So that is the main reason, like we are going to package that code. And other cases, if we are going to use a Docker, if we are going to containerize the container, then in that case we are going to create something called a Docker file. And again, the main idea behind it is to take all the code and dependency and merge it together. And the advantage of doing that, so that wherever we are deploying, either from developer machine all the way to the different environment, it will bring all the dependency along with it. So that whenever we are deploying like for example, our ultimate goal is to deploy into production. And in production, there should not be any conflict, or there should not be any dependency issue, or it should not, ultimately the code will not fail into production. Okay. So in most of the cases, the deployment is either done in nowadays in most of the popular cloud providers. It can be your AWS, it can be your Google Cloud, it can be your Microsoft Azure. Or if you're containerizing the application, then in those cases, the code will be deployed in the Kubernetes. Kubernetes is one of the popular place orchestration system, which is going to deploy your Docker container. Is it clear so far? Like we have reached all the way where you have write the code in your laptop to all the way we have deployed that into our production environment. And this is a cycle which is common at all the places. Like this is a standard industry workflow, which is followed by all the companies. There may be some additional thing in here and between, but this is a normal workflow. And this applied to all the language. Any questions so far? Yeah, Priyanshu, that's the next part. So I'm coming to that. So yeah, Priyanshu, in order to do that, so that it will not impact. So like I mentioned, here we are just going through a simple cycle, but before deploying that code from your machine, your development machine to the production environment, there will be a multiple environment. So for example, like mentioned, there is a separate environment called QA environment, quality analyst environment, where your QA team is going to test that code just to ensure that it is not going to impact production. In some of the companies, they have something called SIT environment, system integration testing environment, where they test the code. Uh, in some companies where I work with, they even have something called UAT environment, unit testing environment, where they test the code before it is being deployed. It can be done by the manual tester or the automated one. There is a popular tool called Selenium, which do the same thing. Or in some companies, even I have worked with, they have a business tester who did all the business testing before it has been applied to the production. And I can tell you, there you may heard in future you may heard a term called canary, CANARY. What it will does that rather than opening the website to all the customer, they open it for only, like, let's say, just for the sake of discussion, 5% of the customer. Only 5% of the customer will be able to see the new code. In this way, they will be 100% ensure that the code which is going to production, and especially this is true for financial company. I work for some financial company, and especially for banks, they want to ensure that any code which is been going in production should be completely tested before it is being open to the world. So there are multiple steps which is being followed before it is being deployed, because it's not only the financial loss for those company, but also it will bring the bad publicity. Any other question? Okay. So now your code is deployed, and whatever I have mentioned, everything you have done, everything is fine, but things may go wrong, to be honest with you, and it always go wrong in some way or the another. So what can we do to improve it? First thing is monitoring. We need to keep on continuously monitor our server and application. So for example, let's say you deployed your code into some server, whether in AWS or your own server. That server can go wrong because that is just a physical machine. So you need to keep on monitoring that server, and you need to be flexible enough to ensure that whenever the server goes down, you need to remove it from the pool. Some of you guys may probably heard something called AWS auto scaling. What auto scaling will do, let's say at 9 a.m. During the daytime, whenever the business start, it will automatically add n number of server behind your load balancer. Load balancer is basically the request of the customer goes to that load balancer, and it will eventually hit to your servers. So it load balance the load among, let's say you have 100 server behind the load balancer. So it will evenly distribute the load to the different servers. So auto scaling is one of the process through which you can increase or decrease the number of server behind the load balancer. So basically the gist of it, you want to ensure that you always have the availability, or your server will always be able to handle the customer load. So in order to do that, you need to monitor your server. And that you can do that with the help of some open source tool. Nagios is one of the most popular one. There are other tools like Prometheus and Grafana. And let's say if you are in AWS, they provide their own tool called CloudWatch. And I can tell you, for example, whichever company I work with, in case if the production server goes down, we always have alerts in place. So let's say if it's down right now, it is going to trigger me something called a pager duty alert, which I need to respond immediately within 10 minutes. So it is going to call on my cell phone, and I need to respond immediately. So we have all these monitoring and checks in place to ensure that there's always 100% uptime for our customer. Secondly, even if you provide all the monitoring, there is always a bad actors. And bad actors, I mean, they will constantly hit your website, and their ultimate aim is to bring down your website. And that can be done with an n number of attacks. For example, there is something, most popular one is called DDoS attack, which is called denial of service. So what they will do, they will send out, keep on sending the big amount of payload to your server. And the main aim is that your server will getting so many requests at one point of time that ultimately it was not able to handle those requests. And that will eventually bring your service down. Could you list the name of tools in the chat box? Yes, sure. So the most popular one is Nagios. There are other called Grafana and Prometheus. And for AWS, there's something called CloudWatch. Yeah. So I was there like security is one of the most prime importance. And like I told you in terms of CI/CD pipeline, please ensure that your code that you are writing should not have any kind of a security vulnerability. And the good news is most of the cloud provider like AWS, either it's GCP, Google Cloud, or Microsoft Azure, they provide safety protection from most of these common attacks, like this DDoS protection attacks, or there's something called SQL injection attacks. So most of the popular attacks, they provide the protection for you guys. Okay, I think we just have 12 minutes left. Any questions so far before we move to the next topic, which is AI ops or LLM ops? Okay. So if you understand this part, understanding the LLM ops part will be pretty easy for you. Okay. So LLMs ops is a buzzword. LLM ops, most of you guys have heard about ChatGPT. So LLM stand for large language model. So earlier, you can look at this place where developers, they are providing the code or the DevOps engineer who is writing that code, and eventually that code need to be deployed into the production. Now, in case of LLM ops, they are basically providing a model, and I'm going to discuss more about what model is. For example, ChatGPT, they have a model called GPT-4. So, or if you heard about Meta, like Facebook, they have a Llama, or Anthropic has Claude. I can name any number of models. So basically, rather than deploying the code, I mean, we need to deploy our model, and model is eventually at the end of the day, it's the code. But let's discuss about this. What exactly is this all about, the model and the code? So let's go back to this point. So let's understand what a model is. And you probably heard, most of the time you heard a word called foundational model. And what are those foundational models are? So basically they are a pre-trained model. And when I use the word pre-trained, that means they are trained with a large amount of data. And that large amount of data can be anything. It can be a code. So for example, they will be trained with the data from GitHub. They can be trained from the data of Wikipedia, Stack Overflow. They basically pass the whole internet and feed that data into that model. So that's why you heard about a term called GPT, right? Chat GPT. So in GPT, there's a part called P, which is called pre-trained. And so pre-trained means it has been trained with a large amount of data, and that data is the whole internet. And once you train that model, it is capable of doing n number of tasks. So for example, I can give that model something like, for example, I can ask them to summarize an email, or I can ask them to write a question answer for me. So those kind of a model, we called it a general purpose model because they will be capable of doing any number of tasks. But there's something called a specialized model, which is, for example, Stability AI have a diffusion model, which is only responsible for creating an image. Or you can create your own model. So for example, I'm just giving you an example. Like, let's say you guys are the student of BTech and you have a 8 semester of syllabus. So you can train the model with that 8 semester of syllabus, and it can only give you the answer to that 8 semester. And again, I'm oversimplifying it. Training a model is a big task because it involves a lot of GPU powers, which is really expensive. But it is doable because most of the companies nowadays, they are moving away from like a general purpose model to a specialized model, which is just doing the one task. Let's say a company can develop a medical diagnostic model, which is just going to answer the question related to the medical field or something related to the law. Okay. Now, the important part about to understand all this is, like I mentioned, GP part, which stand for generate. Like whatever you're asking him or her, it is going to generate a response for you. But the most important part of it is called T, which is a transformer. Now, I again pause here for a second. Anyone heard about this transformer and what is the significance of this T transformer part? Because that's a really important thing. Anyone? Okay. So all those who not heard about it, I will say, please read this paper. This is one of the most important paper I will say in the current time, which changed everything. So this is called attention all I is all you need. Now I will go back to the slide. So what this T will does is called, like I said, it's a transformer. This is the backbone, or you can think of it's the brain behind the chat GPT. And it has something called self-attention. Now, if you look at this last sentence, the cat sat on the mat because it was soft. So if you go like just 5 or 6 years back, we have a lot of deep learning models. And the problem with all those models is this self-attention thing. So let me try to explain you in the simplest of terms. If I give this sentence to a model up to this point, the cat sat on the mat because it. So if you give this statement to the old models, uh, um, uh, old uh, old models, okay, just for simplicity, it has no idea what it was referred to. They will think it might refer to the mat or it might refer to a cat. So if you look at this whole sentence, because it was soft, it here refers to the mat. The cat sat on the mat because it was soft. It is the mat who is soft, not the cat. So what I'm trying to explain to you guys that this transformer part has something called self-attention, where if you give it some sentence, it understands the context of that sentence, and it is able to generate the output out of that. And understanding the correct context is really important. So when you ask any question to a GPT, it will try to understand the context in your sentence, and it is whatever the data we have trained it so far, it is able to determine, okay, this is what you are trying to understand, what you're trying to ask to the chat GPT or any of those LLM models. I will not say it is perfect. You probably heard the term called hallucination, where model is giving you the wrong answer, but it's keep on getting better. But the gist of it is that this research paper will change everything. This comes up with this self-attention mechanism, where when you're feeding some sentence to your model, it is able to determine what is the next word in that sentence and which part of the sentence it need to focus. Is that part is clear? Whenever you guys get a chance, please read this paper. I mean, it's really technical. I know it's really difficult to understand, but just give it a shot. It will be really helpful for you guys. And now we have only 4 minutes left. So I will quickly go over some of the key things. So some bonus for you guys. I have wrote this 2 books. It's completely free. So one is called Cracking the DevOps Interview. It has all the scenario-based question. It is based on my 19 years of experience. Whatever the question which is asked in many of these companies, you can name it, bank-based company like Facebook, Meta, Google, Amazon. I put it all together and put it in this book, the top 100 question and some scenario and some real life scenario. So please feel free to download it. If you want to build your own pipeline, like LLM ops we have discussed, I put a step-by-step process how to build it. So again, this book is free. Please feel free to download it. Just one request from your end is please give me some feedback, either it is good or bad. If you like the book, please feel free to please leave the feedback on that page, on the review page. Next thing is, uh, I'm just giving you this idea, but it may not be relevant to you guys. Uh, for most of the interview preparation related to the coding, this is one of the book which I heavily use. It's really good. It's by Gail Lackman, and she worked for many of the tech companies here in Bay Area, and she's really good. So unfortunately, this is a paid book, but if you guys are interested in interview preparation, this is really good book. And most of the question in it is from this lead code. I think you guys probably heard about this lead code platform. Most of the companies, at least I can tell you here in Bay Area, or I know many companies in India, they ask questions from this lead code platform. I'm not sure it is still relevant for freshers or uh, people in the academic background, but this is one website where you can improve your coding skills. So one is this lead code. The other, maybe you guys have heard about it, Geeks for Geeks. So Geeks for Geeks is here also you can find a lot and lot of coding questions. And I will not ask you to go for premium subscription or anything for that, but basically this is where you can find a lot of coding practice questions and everything. Next thing is I want to share it with you guys. Maybe it's not relevant for you at this stage, but there's one other good book called System Design Interview. So mainly after you gain some experience, like this is mainly for people with 1 or 2 years of experience. Unfortunately, they started asking these kind of a question to freshers also. So in the interview, specifically for DevOps engineer and now even for coding round, they have a special round called a system design round. So they may ask you a question like, for example, design a new Google for them, or design a Facebook or a Meta for them, or design any parking lot system. So this book has a collection of all those questions, like how to tackle those kind of a problem. Again, it may not relevant for you guys at this stage, but just a food for thought later on down the lane. If you want to see like how these companies they have built their own designs, this book may be relevant for you guys. So just some of these platforms which may be helpful for you. Yeah. And before I wrap up, any question for me? And yeah, like I promised, this is my LinkedIn profile. Let me ping you guys. Yeah, I was about to ping you, Rakam. Yeah, please feel free to connect to me if you have any other question after this webinar. Just shoot me up and I will try my best to answer that question, those questions. Yeah. So yeah, like I mentioned, thank you all for joining this session. I mean, I really enjoyed this session. I tried my best to answer all of your, I tried my best with my ability to explain you guys in the simplest of terms. If you follow these rules, this is the standard practice which has been followed by all the companies. So this is where everything is. And I will wish you guys all the best for your future endeavor. Whatever path you guys have choose, you will have a great success in that path. And again, I would like to thank Jaypee University for giving me this opportunity. And I would like to give a big shout out to Isha Gupta, who worked with me and she does all the coordination behind the scene. So thank you, Isha. And thank you, guys.
Thank you so much, sir, for sharing your valuable thoughts with us. I hope this session will positively add values in our students' life and help them to excel their skills in future. Thank you so much, sir, for adding and making yourself a part of this meet session. And once again, thanks everyone being part of this session. Thank you, sir.
Yeah. Thank you, guys. Thank you, everyone.